Welcome to the webinar, Fostering Cooperation and Efficiency Through Implicit Geology Modeling, sponsored by CIM Magazine and Dassault Systems Geovia. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine, and my co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Just a little housekeeping before we get started. If you joined by computer, make sure you've selected the computer audio button. If you joined the audio by phone, please make sure you selected the phone button. If you have questions during the presentation, please type them into the GoToWebinar control panel question box. The questions will be held until the end of the presentation for the Q&A period. Now I will turn the webinar over to Ryan to introduce today's presenters. Thank you.
All right. Thank you very much, Michelle, and thank you everyone for joining us today. Today's presenters are Garrett Kramer, who is Geovia Technical Executive at Dassault Systems, and Paul Abongwa, Geovia Industrial Process Consultant at Dassault Systems. So without further ado, Garrett, over to you.
Okay, thank you, Ryan. Can you pass the screen control over to me? And welcome, good morning, everyone. So we're here to talk about how we in Dassault Systems view cooperation in terms of our implicit geology modeling. And without further ado, I'll let Paul introduce himself briefly and his background.
Thank you, Garrett. So I'm Paul Abongwa. I'm currently a Geovia Industry Process Consultant. I'm based out of Montreal. So before joining Geovia, I started up in the geoscience sector a long while ago in high school. I obtained my BSc and an MSc in volcanology petrology at the University of Yaoundé 1, during which time I started off a brief career in the oil and gas industry for SIM consulting. I later on moved to Sweden, where I obtained an MSc in natural resource engineering with a specialization in exploration and mining, during which time I worked as a research geometallurgist for Northland Resources. Then I moved to Canada, where I decided to start off with the consulting in the geoscience and mining sector, which I did work for MRB, an associate, and AXO expert conseiller. Then later on, I decided to go into the direct mining mainstream, which I joined Tata Steel Mineral. Within that time, I also decided to grow inorganically, which I obtained an attestation in project management and an executive MBA in business analytics. Thank you, Garrett.
Thanks, Paul. And my background is I guess a little less than 3 decades that I've been involved in my geoscience career. You know, it's definitely my industry highs and lows have definitely impacted it. As you can see, I plot my career history as a function of either the Brent crude price or the gold price. But with that said, however, I've always striven to improve upon the norm, right, in my research and career in the natural resources. And this is both across upstream oil and gas, geothermal, and mining. And like most in the natural resource extraction industries, right, I find it a great adventure experience other cultures and living in other parts of the world. I'm currently based in Denver, Colorado. So about Dassault Systems, we think of ourselves as what we call the 3D experience company. And really what we are is we're a purpose-driven, and we think of progress and innovation in terms of the balance and impact that we have with our customers through our software tools. We're roughly 20,500 now strong. The company is full of passionate people from 135 countries across the globe, and at the heart of the company, we're growing, unlike most of the so-called tech sector. Right? So we have a large R&D team connected across roughly 72 laboratories, and Dassault Systems has roughly more than 300,000 customers across 12 industries. Right? So a fundamental aspect of Dassault Systems is partnering with clients who really lead in their industry segment and who progress on the cutting edge of technology and answering tomorrow's needs. And we, you know, whether they're industries titans or startups, we tend to partner with them in the different domains and spaces. So our 15,000 selected partners really, they increase our collective knowledge and reach in the areas of the technology, sales and services, and education and research. So, and an important point about Dassault Systems is that the composition of our shareholding has been really consistent since the introduction on the stock markets globally. So, and the majority of the company is owned by the Dassault family and the company's senior management. And so this stability enables really a consistent long-term strategy and long-term investment, enabling us to be one step ahead of the competition. So we call ourselves a 3D experience company, and we represent that with the compass symbol on the left. And what it really does is it powers the different 12 brands that we're composed of, really according to what they stand for. We have social and collaborative apps in the north, 3D modeling apps in the west. That's where the Geovia brand sits. We have simulation apps in the south, and information intelligence apps in the east. And we really serve 12 different industries primarily with tailored solutions that address their specific challenges. And Geovia specifically provides value in 3 sectors of industries currently: the cities and public services, infrastructure, energy and materials, and the AEC industry. Now, Geovia came to be, it has a long history. So in 1985, a software company called Gemcom was founded, and it really became a leader in the mining software industry. Through the 90s and early 2000s, Gemcom purchased and acquired various software companies and strengthened its position even further as a market leader in primarily the geology and mine planning software industry. And so you've probably heard of products like Surpac, GEMS, Whittle, Minex. Those are among the very first generation of mining software products that were used globally. In 2012, Dassault Systems acquired Gemcom, and they launched the Geovia brand with an initial focus on the natural resources market. And Geovia remains one of the geology and mine planning software market leaders to date. You know, we have an estimated roughly 17,000 users worldwide between our various software products. And now, in the recent past, right, driven by our promise of modeling the sustainable planet and improving the way things are done, Geovia continues a transformational journey by essentially migrating our tools and technology to what we call the 3D experience platform. And I'd like to now frame why our mining tools are moving in this direction. So the mining industry plays a crucial role in the global economy. There's no doubt about that. And also the race to decarbonize. Right? This drive and demand for critical minerals in particular, right, it's placing responsibility on mining companies to decarbonize their operations and reduce the overall carbon emissions along their supply chains. This shift has a profound impact on the entire supply chain. So if we take, for example, the increasing demand for electric cars, right? While the demand is rapidly rising, the limited available of the raw materials for batteries, such as lithium, nickel, cobalt, right? It's becoming a major bottleneck. And this scarcity really threatens to impede the widespread adoption of these vehicles. So, and according to the International Energy Agency, right, soaring demand for electric vehicles by 2030, it's going to require the development of at least 50 new lithium projects, potentially 60 nickel mines, and up to 17 cobalt developments, right? These figures may change somewhat, right, if solid state battery technology matures quickly, but regardless, right, the mining industry typically takes 15 years to develop a new project, and this presents a significant challenge, right? This is leading the EV manufacturers to bypass traditional supply chains and engage directly with mines to secure the primary materials that they need in offtake agreements. So consequently, the price of mining production is no longer solely governed by the commodities market itself. So mining operations have now become an integral part of this complex and interconnected supply chain. And this level of demand really requires mining operations to respond effectively and efficiently. Furthermore, mining companies are setting ambitious goals to reduce carbon emissions, right? Now the question arises, where do we start with that? How do we respond to all these pressures and approach decarbonization in a productive and efficient manner while considering all these other challenges? One can argue that digital transformation is required. While all industries are undergoing some level of digital transformation, certain sectors, including mining, we think require a more extensive evolution. So we firmly believe within Dassault Systems that innovation is the key to decarbonization of the future. Right? However, innovation cannot happen in isolation. And the point of this webinar that we're trying to emphasize is that collaboration is essential. Collaboration across siloed departments and within teams. And as you'll see in the upcoming Implicit Geology modeling tool, how we're going to demonstrate how collaboration can be effectively achieved within an organization. And the fact is, right, that the process of mining, from securing permits to maturing and developing a mine, through exploration, development, and production, through to decommissioning and site rehabilitation, is really a series of interconnected systems and decisions. So it really is a system of systems. And as you'll see, that's why our tools approach it like this. So our geologic asset solutions within Dassault Systems, they really provide tools that help to understand where the ore is, how to create a plan efficiently to extract and operate the mine, and how to optimize this process from pit to port. We also have mature solutions that address capital projects and facility needs, with examples like electrical power plants, refineries, mine infrastructure, ore handling equipment, smelters, etc. Right? This portfolio really aims to cover all aspects of the project execution, from the engineering, the construction, commissioning, and up through asset integrity. And we feel strongly, right, that collaboration across these domains and processes is critically important. With that, I'll hand over to Paul to demonstrate how we've implemented this collaboration methodology for our implicit geology modeling solution. Over to you, Paul.
Thank you very much, Garrett. I want to believe that everybody's seen my screen. Good. So I will start off. I have a very strong safety culture from mining, which I always like to start off my presentation with a little bit of safety share. So for some of us that are just coming off the winter season, the summer always comes with a lot of different challenges, little gardening coming up, or maybe some minor renovation around the house. So just make sure that you have the right tools for the job, and as well, you have the right personal protective equipment to perform the job safely. So moving on to what we're talking about, fostering cooperation, or in other words, collaboration, to achieve efficiency, using implicit geology as the tool or technique. I always tell people that whatever we do, cooperation, or collaboration is just a word like any other if it's not used appropriately, or if it's not integrated at the right level in your process plan or in your operation. So I'll start off with a little story back in 2016 when I was working up at the Labrador Quebec Trough. So then the iron ore market has just, the prices has just hit rock bottom, and there was this struggle, to keep most of the iron ore mines in the world, and specifically on the Labrador Quebec Trough, open. So in our operation that we were doing, we had the pits were about maybe 25 plus kilometers from the actual process plant. So the distance alone becomes a challenge. And we had a process that we had the direct shipping ore and the beneficiation plant. So to be able to stay open and stay operational, we had to identify, pockets of satellite pockets of high-grade mineralization just around where we had the wet plant. So I started putting some structural implications in some of these old pits, and I later on identify one of them that could help us, cut down the operational cost and to be able to, achieve our target. So I asked for the drill rig to be moved over to that location and started drilling to test, the assumptions that I had in mind to be able to identify these pockets that I was looking about. So not too long from then, a colleague, went to, was just passing by that pit and, went to the rig and had to stop the rig and ask the drill rig to move out of the location that, there was just too much, maybe overburden that was being drilled. So this actually is a typical example of cooperation, how cooperation, integrating cooperation in the process, early enough, can help avoid some of the inefficiency that was actually happening. So, but what was the actual results that we did obtain after engaging in a cooperative and a collaborative manner? We're going to come back to that shortly, but before then, I just want to explain implicit geology modeling, in the geoscience part of, be it from the mineral exploration or be it from the mine operation. These three major activities that we have to capture, is data captured and data management. Apply this data, and at the end you communicate the results. So be it from import and manage geoscience data, be it visualize this geoscience data, validate this geoscience data. These are not activities that should be done in silos. These are activities that right from the beginning, that collaboration and the cooperation has to be introduced. And that is where the 3D experience platform offered by Geovia comes in, offered by Geovia and Dassault System comes in. This is a platform that gives you that opportunity to be able to establish this collaboration right from the onset at the right level for it to achieve that efficiency in your implicit geology modeling. So now we need to understand, the mine value chain. Your mine value chain is just as good if you do understand the level of cooperation that you have to integrate. The level of cooperation can be, departmental, it can be interdepartmental, but in a successful mine value chain, you have to make sure that that interdepartmental cooperation especially exists. So a simple mine value chain, you can start from mineral exploration, which sometimes is viewed out of the box from the ray operation. You have the mine operation processes, you have the process and the beneficiation operation processes, you have the logistics and marketing and sales and operation processes. Now, where does the geoscience or the geology knowledge really comes into all this? If you go into your mine planning during your drilling, your drill and blast, your excavation, your loading, your hauling, feeding, processing, and your end result, you realize that the geology is an integral part of this process. The geology is an integral core activities which, to my opinion, exist like that monitoring and controlling phase of each project or operation. So it does not only exist by itself, but it's also necessary to be able to bring in the service and the support activities that helps to understand your mine value chain and what level of cooperation and collaboration is necessary at each point in time. So now narrowing down to the Geovia geology modeling solution, we actually capture this solution on our platform under two main roles. You have the geoscience referential manager role, and you have the geology modeler role. So in an overview of these roles is they are all available on the cloud and on premise. Available on the cloud means they are fully integrated within our 3D experience platform. It's a very fast implicit geology model, which can reduce your modeling time by about 95%. You can easily visualize and analyze, your drill hole displays and different kind of interpretations very quickly. You can, incorporate different explicit modeling solutions from different softwares that you're using. But the main thing with this is it being available on cloud means your availability and use of availability in your corporation, it's very high. So this modeling solution can be captured in a very simple process outline. We have in our data administrative app, we can capture the different attributes that we want to use in our interpretation. We can import the boreholes, we can create data set, and we can manage access to the different levels of permissions that we have within the cooperative and collaborative 3D experience platform through creation of a collaborative workspace for all the team members that are involved within the task that's supposed to be performed. You in the geoscience interpretation app, you can actually, view your database. You can, define different interpretation, be it geological, be it numerical, be it structural interpretations that can run concurrently to achieve, the results in a very quick span of time and collaboratively. And then the geology modeling app, you can now create all these, use these interpretations that were generated, and you can generate your block, your geology models and different iterations to achieve the right models and use the what we usually call the up-to-date data that you have available to achieve your results. Now, I'm going to, demonstrate this in a very quick video. So the implicit geology modeling collaboration, starts off by, creating a collaborative space. You can create your collaborative space for all the users that are, that are involved in the project. So once you create your collaborative, just 1 minute. Once you create your collaborative space, you can then assign the different members of the team that are involved in the project, and you can assign tasks, for each of the members. So each member understand, what they're supposed to be doing and what is the time frame for the task that are supposed to be performed. So once you assign the task, immediately the member will receive, an email that is informing the member there's a task that has been assigned on the collaborative platform. Once the member log into the platform, once the members start doing the work, you can go in and see, your revision and your life cycle management of what is happening with the work. To start, you can create a revision as any other good practice of the task that has been assigned, to establish that traceability in your workflow. So once you start doing your work, your supervisor can then see what is actually going on. So this is just a process of going through to do the actual revision which has been assigned to you. You can choose what part of the drill holes you want to display at what time, depending on what sector you want to update or assign. You have different ways that you can view the drill holes, be it by creating composite or just by adjusting your lithologies. You can create your interpretation. So you can create your interpretation, like I mentioned, which can be geological interpretation or can be numerical interpretations. So once you create your interpretation, then you can then make sure that your interpretation is either lithological or it's numerical based on the interpretations that you want to do. So once you create your interpretation, you then have to do your interpret the lithology. So several interpretations can be done at the same time. You can do the lithological and you can do the numeric interpretation at the same time. So you can then choose which option you want. Either you want to do your numerical or you want to do your lithological interpretation. So this is just to understand briefly, the different processes that we do with our implicit geology modeling software. You validate your interpretation, and once your interpretation is validated, you then have to go into the geology modeler tool, which I introduced earlier, to generate your interpretation. So it's also very easy for you to determine the extent of the area that you want to interpret. It's very easy within one click to determine the extent of the area that you want to interpret. So once all that is done, you go into the geology modeler where you have to start doing your modeling. You can start off by reviewing the old model which you had in the system, review the structural models that you had, create the extent. If you want to take out some of the old drill holes that you don't want to use in your interpretation, you can take those out. You can determine whatever extent you want to interpret. Then you use the basic principles of geology. You define your geochronology, which is just the superposition of the beds. After doing that, you can create your structural zones. Everything is done concurrently. You can create your structural zones within that same interpretation. You can set your parameters on how you want the beds to relate within each other, and within a single click, you generate your block model, your up-to-date block model, which you can view either in vertical sections or in plane. So once that is done, your job is now done. You go back into your collaborative space and you update, your the task, which moves into complete, and immediately your supervisor receive a message that the task has been done. We'll now go into the collaborative space to validate the job that was done with respect to the task that was assigned. So you can see the comparison within the task that was that was assigned to perform. So once your collaborative task is done, you can then go back and then complete the task as assign the task as completed, the maturity level of the task, which you can easily attach. Since all this information is on the cloud, you can easily attach the updated model and share with the entire team that you're working with. So once this is done, you move into your life cycle to update the maturity level of the task that was given to you, so which you just have to update now as released. So once you update your maturity level, you can then view the project in your collaborative space, and you can share with your different colleagues, be it departmental and interdepartmental colleagues that are also part of the project within one click. The beautiful thing in the whole thing as well is you can capture all your lessons learned as well on the platform itself, on the collaborative space. So in this case, there's repeatability in your process and there's traceability in what was done within your process. So the next short video, I will just want to show you a quick highlight in further collaboration that, sorry, I keep going out of. So in a nutshell, what I want you to take away from here is that collaboration is actually very important depending on the level of how it was being introduced. You know, it boasts teamwork right from the beginning of the project. It's very quick. You know, the most important thing is the collaborative, quick, and reliable models that we can quickly generate in real time, and a single source of the truth in the process. And all this is achievable on the 3D experience platform, which makes this collaboration a very important aspect for teamwork to be achieved and to obtain the best result in your processes. Garrett?
Yeah, and I always like to end presentations with some field photos. So here I am at a recent field trip to Asarco's Ray mine in Arizona. It's quite a large pit after 125 years of producing copper, and I really appreciate them sharing the experience with us. And I also list our email addresses for those who'd like to reach out for additional details on any of our solutions. Thank you for your attention. And Paul, there's one last slide if you want to advance it. And so, yeah, thank you for your attention. And now we'll take any questions that you may have.
All right, great. So we do have some coming in. One of them is around how you capture the data from exploration. Is that manually and then translated to Geovia? Sorry. Or do you have a mobile app used on site, or just how does that work?
Okay, Gary, do you want me to go for that?
Well, let me say something, then you can fill in the holes in my answer. So drill hole database, we work with drill hole databases. So if you have a drill hole database that might be in, maybe GeoSQL or Acquire or other solutions, right? We have direct API connections to our implicit modeling solution that we pull that information in. Do you want to add something to that, Paul?
No, I think that's that's answered the question.
And does your data treatment integrate geostatistic tools?
Paul, you want to address that one?
Yeah. So presently, we're working on the geostatistics option, which is something that's going to come out sometime this year. But we do have presently basic geostatistics, which is just to involving viewing of the drill holes. Yes.
Okay. Great. So I've got a couple questions, I think, that sort of follow the same line. It's just about compatibility. Can you import a geological model made with another software? Does that work?
Yes, we do have that ability now. Like for example, we have SOPAC, which is still part of Geovia, and we can do import explicit models that's made from SOPAC into the geology modeler tool. Yes, we do have a lot of connectors that we can do that.
And it goes both ways. You can import it into SERPAC, you can export it to SERPAC.
Yes, so we did limit not to really show, we can do a full demonstration of how the geology modeler works itself. This presentation, we try to limit ourselves just to the collaborations. So at the end of each process, you can actually export this data in different forms based on the different software that you want to use it, either for your block modeling or for your mine planning.
Okay. And I don't know, Garrett, this one may speak to you directly, about the internet connection. Like, are there, yeah, bandwidth, I guess, a baseline requirement for using the.
Yeah, so our cloud-based tools, right? It's we have tests. Obviously, you do need some connection to run a cloud-based application. But in our tests at various places around the world, we found most mine sites, it's actually quite sufficient. I mean, and you can, because it's a cloud-based solution, right? You can even, if you wanted to, you could run an implicit geology modeling from your phone or an iPad if you wanted to, right? It doesn't require it requires a web browser, right, and a login to the 3D Experience platform. So if you can achieve that, and you're able to connect your drill hole database to our platform, we haven't run into any major bottlenecks there, I would say. And just let me comment, so we specifically showed off our collaboration with our implicit modeling tool here, but we also have a number of other tools, such as SURPAC, which actually sits on your computer. And those tools, while those licenses are generally managed through our cloud system as well, you can take those licenses offline, right, and check them out for a month or two if you need to, if you're going somewhere quite remote.
Okay. So a SURPAC user who works from a physical workstation asks, is it possible to get access to modeling only, or do you require to implement the entire platform first?
That's a good question. So so the implicit geology modeling solution, it is a cloud-based solution. So you can't isolate yourself from the 3D Experience platform with our implicit modeling tool. So, and that, I say cloud, right? It can be hosted on DASO, systems, servers, or it can be installed, on your own servers, or so an on-premise installation. But we found that really the on-cloud DASO hosted scenario really works best for most clients. And so isolating the implicit geology modeling application alone, I would say I don't think that's possible to insulate it from the 3D Experience platform. Would you agree with that, Paul?
Yeah, I just want to add that, we do operate a number of roles because, roles based. So the geology modeler is a role, the geoscience referential manager is a role in addition to different roles. Yes, you can have the geology modeler role, if you want just the modeling role, but you have it on the platform, but you can have that role on its own on the platform.
So an interesting question here about the collaboration. The Collaborative platform demands a different workflow within technical teams. Can either of you comment at all on your experience related to change management required to implement a collaboration tool like this?
Yeah, certainly. Change management is a very important aspect, both within the team that's utilizing these new applications, but also the other teams and other departments that are consuming the outputs downstream of those processes. And yeah, change management, it can be a heavy animal, right? Or it can be a lightweight implementation or a challenge, right? It's been my experience that the culture of the organization and their willingness to adopt different solutions and ways of working has a heavy impact on how the implementation goes. But change management is certainly an important aspect that we consider, and it's actually part of what we call our value proposition and value engagement process when we walk through it with clients.
Yes, I just wanted to add that that's the value engagement. So the good thing is that, Dassault Systems and Geovia has dedicated specialists, to identify these steps with you and make sure that, we go through with you these steps, for the necessary changes and the necessary benefits that, you're going to obtain thereafter.
Okay. So question about what are the I guess most important parameters for data collection for this?
The most important parameters for data collection?
Mm-hmm.
Yeah, so we believe in the single source of truth. The single source of truth means, like I always tell people, decisions that you make is only as good as the data that you used. So you can make the best decision if you're not making it on the right data, it's just, it's not valuable. But if you make your decision based on the right information, that's very important. So this is not really a data, like we said from the beginning, this is not a database, app. This is a geology modeling app, which we have the geoscience referential management, where we can, bring in the data in a single source of truth repository, and everybody within that that have access to that single source of truth, which is the data that's being used and validated all throughout your process, right up to the modeling results.
Yeah, and I would say one of the powerful aspects of our single source of truth, allowing collaboration and then putting the implicit modeling tool in the cloud, it really allows for a rapid iteration. So as new drill hole data comes in, for example, that can be quickly incorporated to update a geologic model relatively rapidly. We're talking on the order of minutes, not hours.
Yes, and just to add more on that, for instance, in most projects, for instance, most mining project being open pit or underground, sometimes before you even have the results for your blast holes, you've already moved out that material. And most, production geologists, because of the level of effort that is needed to use this updated information, some of them, tend to neglect them. But with the ease of use that we have within the geology modeling setup, it gives you that ability to quickly update your information using the live data that's being generated, and in most cases to achieve the most up-to-date results in your operations.
Okay, great. So yeah, you can if somebody wants to get hold of the presentation, they'll be able to reach out to you, and we'll also be have this recording for people to consult afterwards. All right, I've got another question here. So yeah, a question about just the accuracy of the modeling as compared to yes, I guess the on the ground. We're speaking of truth. The on the ground truthing. How accurate is the modeling compared to the real world, or how do you prove that out?
If I can just comment, right? Implicit modeling, right, is it's different from explicit modeling. So implicit modeling uses all the data you have available, right, and it in a way, you can think of it as automatic. It uses geologic principles to interpolate, right, between known drill hole points, essentially. And the power of implicit modeling is it allows you to rapidly assess different scenarios or understandings of the subsurface and be able to design either drill hole programs, surface mapping, or geophysical techniques, right, to test those different understandings of the subsurface, right? And so accuracy of an implicit model is you know, it's a function of the data that you put into it.
Yes, and just to add on that, you know, I always tell people modeling is not, you know, creating what you know. It's about generating geometries that are close to what you think based on the data that you're using. You know, so generating these geometries, you know, also depends on, you know, how good the data is and how good the person interpreting this data is. You know, we have we have models that we can create through, you know, implicit modeling. We have the SOPAC software that we can actually create through explicit modeling as well, and you can compare this information. So these are things that we're willing to compare to prove how close this is. But the most important thing is how quick you can generate, you know, a different model. So for instance, in explicit modeling, you can take maybe 6 months or 3 months to generate a model, but within the implicit geology modeling tool that we have, it's just a matter of minutes and you can generate 15, 20, 30 different models based on the updated information that is coming in. So I usually tell people that, you know, when you do your economic assessment, what you have, if the time that you finish your mining, you still have the same model, it means you did not do a good job in mining. Because no matter what you do, as information is being added into the system, as information is being changing, the more you're closer to a geometry that, you know, gets closer to the reality.
Yeah, and another approach at that question is along Paul's lines is, right, the idea of modeling, right, is it's a decision support tool for the mining industry, right? And so what level of accuracy do you need to either support or allow you to make a decision in the process that you're trying to achieve? And we argue that being able to rapidly iterate, generate a number of scenarios, and collaborate and share those outcomes with across the team and across departments, right, there's a value proposition there for the mining industry.
So one question, this is a software as a service model. Is that correct?
So there's different types of commercial engagements. We can carry out the service for you, or you can essentially lease the tools, right, to carry it out yourself.
Okay, so you mentioned the lease. Somebody's curious about what if they just need it for a short period of time. I guess just the lease lengths.
Yeah, lease length, and given the nature of the 3D Experience platform, the lease length, the shortest I've seen it is a quarter or 3 months. So it's a little bit different implementation, because I know some of our competitors in the implicit modeling space even, you know, go down to the day sort of thing. But that's a bit of a different animal, because that's just the implicit geology modeling functionality. Whereas our tool really is about carrying out the implicit modeling and also then being able to share and collaborate with that essentially downstream decision tool.
Okay. So I see. So your emails are up on the screen there, and I assume that if anyone has any more questions about your offerings, they ought to reach out to either one of you.
Yep, that would be great.
Okay, perfect. Well, I think I don't see any more questions coming in. I really appreciate your time. It was great. Michelle?
Okay, well, thank you very much for your attention today, and we appreciate the opportunity to share why collaboration is so important in the mining space for us.
Thank you, Garrett, and thank you, Paul, and thank you to Ryan. I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow. For more online presentations, visit the CIM calendar of events at cim.org. We hope to see you at our next CIM Magazine Solutions Exchange webinar. Have a good afternoon. Thank you.
Thank you all.
Thanks.
Thank you.